Hey, everybody, we're going to do 3.5 today. So let's get started. This is literally just a transformation of graphs, okay? So we're going to learn how to transform that parent function to create all those children that we talked about. The parent function of a quadratic is y equals x squared, or either f of x equals x squared. So the function itself is x squared. So how you get the output values is you take the input value and square it. Well, that would give us the resulting table. However, if we took that same function and added 1 to it, what do you think would happen? The answer is that taking those values and adding 1 to them just takes our entire function and shifts it up 1 unit. So adding 1 to the entire function says, hey, let's move up 1 floor. And if you could imagine that, then you could also see how taking that entire function again and subtracting 1 would basically shift it down. Okay, so we would have these values. I kind of messed that up. But we have these values now. So you can see that better. There we have it. So subtracting 1 from the entire function shifts it down 1 unit. Now, these are called vertical shifts. You get this when you take the entire function, whatever f of x is, and you add or subtract some value. I'm calling that value c, but you can call it anything. Anytime you add or subtract, you're moving your value, your function itself up or down. Now, if we go into the function and fluctuate with only the x value, so the difference between x squared and let's say this one, we're going to put that +1, but on the inside of the parentheses. So we're only affecting the x value before we do the function. Then that is what we call a horizontal shift, because x is the horizontal axis. So that should be easy to remember. Okay. So shifting that now allows our function to move left or right. Now, you would think that if you're adding, this would move to the right. However, it does not. It moves to the left. Okay, it does move to the left. So that is counterintuitive. Counterintuitive. Lord, I can't spell backwards, okay? Sorry. That is backwards of what we would think, okay? So adding makes it move to the left. Okay, so +1 on the inside of the parentheses. Now, that is kind of like that whole idea with the vertex. Remember, I said it had a negative in the formula itself. So then when it's negative, that means the value is actually positive. And when it's so it's the same idea. It's backwards because it's inside of that parentheses. Now, if we want to move it to the right, then that means we subtract a value. So taking that and subtracting a value makes it move to the right 1 unit, okay? So we can summarize this and put this all on one slide. If you take the entire function and add something to it, then it's going to basically shift it up. Shifting it down will be subtraction. Now, if you go inside of the parentheses with the x and change only the x value first, adding to it moves it to the left. Counterintuitive, I hate it, but that's what it does. Subtracting from it moves it to the right. This is your summary sheet. Take this, put it on your wall. Okay. Next, we're going to be stretching and shrinking. We've talked about this already. At a value, that a value is going to make our function narrower or wider. So if the number is greater than 1, then it actually, just a second. All right, so again, if you take that 2 and that number is greater than 1, what it does is it stretches it by a factor of 2. So let's look at what those coordinates do. Instead of 4, you get 8. Instead of 1, you get 2. Instead of 0, you get 0. 1, you get 2. And then 4, you get 8. So what happens is, in effect, our parabola now looks narrower. So numbers greater than 1 stretch the function. Numbers less than 1 are going to shrink the function. When you stretch it, it makes it look narrower. And when you shrink it, it makes it look wider. Okay. Stop and pause the video and see if that makes sense to you. Okay. So making multiplication by 2 makes it narrower, called a vertical stretch. However, if we do 1/2, let's see what happens. Our values are half-end. So we get 2, 1/2, 0, 1/2, and 2, which then makes it look wider. Okay. And so notice that this is a vertical shrink, or like we also call it a compression. A compression is something when you press on something and it becomes wider. Okay. So these are just transformations. The last one I think that we're going to really focus on is a reflection. So the way you take something and you flip it, this is something that you've learned a long time ago, probably in junior high. Reflection means to flip. So if you have a value, let's say we're dealing with a square root function and we want to flip it upside down, we put a negative in front of it and let's see what that does. So instead of 0, 1, and 2, our values will be 0, -1, and -2. So our graph will then look like that. It would be a reflection across the x-axis. A reflection across the x-axis. So we're taking our whole function and flipping it upside down. Well, if we wanted to flip it across the y-axis, then we need to make that change to the x only. So like if we went in and put the negative inside, then instead of this, we would have a reflection backwards across what we call the y-axis, okay? And that's a horizontal change because we're making the change to the x. So horizontal changes when you do something to the x value specifically, and vertical changes happen when you do something to the entire function, which is in turn y. Okay, so here we see that example. We're going to take our x values and we're going to flip them. And so what happens is we end up with a backwards function that flipped horizontally across that axis. So this one is called a reflection about the y-axis. All right, so, I'm sorry, you might not get a chance to write that. That's a y-axis. This is the y-axis, but that just means it flipped horizontally. So it went from there to there, okay? So horizontal change again. So anytime you want to make a horizontal change, you change the x only. Vertical changes change entire function. Okay. All right, so example 9 is for transformations in general. So we're going to be taking these functions and we're going to find the equation that defines that function based on the transformation. So this function we know is regularly absolute value, but it looks like it has been moved from the origin up 2 units. So moving up 2 means you're going to add 2 to it. So the original function has been moved up 2. So we end up with +2. Again, now this time we're taking the absolute value function. It looks like we flipped it upside down. So we flipped it across the x-axis, which means we're going to take the entire function and to put a negative in front of it. But then we also shifted it horizontally 2 units. So that means we need to go into the x-axis, to the actual x and subtract 2. Remember, subtraction of 2 means to the right 2. The negative means flip. So from this original function, oh Lord, I cannot draw this. So I can't really draw that, but I'm sure textbook has it for us right there. Absolute value of x, flip it upside down. And that means to put that negative in front of it and translate it to the right 2 units means to go into. So let's try C. Let's pause the video and see if you can do C by yourself. C is the cubic function. So normally it would look like that, but it looks like it's been shifted quite a bit, actually. We've shifted it down 3 units and to the right 4 units. So we're gonna say down 3 units would be -3. But to the left 4 units means we have to go into the X value and add 4. So you see the -3 to the left means +4, but that has to go with directly with the X, because if you add 4 to the outside, then that moves it up. And we actually wanted to move it to the left. D, to me, looks like the square root function, but it's just shifted up 3 units. So we just say +3 on the outside, not specifically with the X. Okay. Example 10 says, how about we take this entire function and multiply it by 2? So we know that that means it's going to stretch this function by a factor of 2. So the original point was 2, 2. Our new point will be 2, 4. This point was 0, -2. The new point will be 0, -4. This point was 1, 2. I'm sorry, 2, 1. The new point will be 2, 2. So let's see this. You basically take that Y value and multiply it by 2. Uh-oh. So it basically stretches by a factor of 2. So in B, you're basically taking those values that we just got, the 2, 4, the -2, 4, the 0, -4, and the 2, 2. And you're gonna just flip them upside down. So this point will now be up here at 4. This point will now be down here. This point will now be down here. And so you can see that this graph will basically flip upside down. So not only did we stretch, but we also flipped. Okay. So we can see this graphically, but you can also see it from a table. So from a table, 2f of x just means multiply all the values by 2. And then -2 means to negate them. So change the sign. And there you have your new points. For example 11, we're going to be looking at 2 different functions. So the original function is f of x, and then we're going to make a new function called g of x using what the equation tells us to do. So we're going to take these values of f of x and x and make the change based on what this is saying. So g of x will now become f of x plus 2. So our x values are now changing. So instead of -4, what is -4 plus 2? That becomes -2 here. And -2, we already have the value that matches with that, so we know that that is 1. Well, actually, let me pause. Let's look at this from a standpoint of just taking it graphically, okay? So you can take these values and let's just graph them, okay? When you have a table, because it's easier to see this way. You have a table of values, just graph those points. Okay. Now, this +2 means take all those values and shift them to the left 2 units. So let's do that. So all those points are just going to the left 2. Uh-oh. So now this point, this -4, 2, got shifted to the left 2 units, so it became -6, 2. -2, 1 became -4, 1. Y'all see what I'm saying? 0, 0 became -2, 0. And 2, 1 became 0, 1. So these became my new points because I shifted everything to the left. So really, if you have a difficulty understanding it from a table, you can always go to a graph and remember what this means. So +2 inside the parentheses means shift to the left 2 units. Pause that and rewind it and try it again. Okay, here we have another one. We're gonna take those values that we shifted to the left 2 units, and we're going to subtract 3. So we're going to actually take our entire function value and move it down 3 units. So for x equals -6, g of x is equal to -6 plus 2, which will become -4. And then we take that -4 value, which is 10, and we subtract 3 from it. So let me show you what this means. So we're going to put -6 in for x. Okay. And so that becomes f of -4 because we did +2. So we shifted it. Okay, we got -2 now. I mean, -4 now. Then we take this function value from the table, which is 10. We substitute that in and we get just 10 minus 3. And that gives us our value, which is 7. Okay. So let's do another one. Let's say x equals -4. So now we're going to work with -4. Okay. So that means that we have our same function that we're using for g of x. We're going to say our x is now -4, so we just plug that in. What is -4 plus 2? Well, that is -2. So we now have the function value of -2 minus 3. What is the function value at -2? It's 8. And we got that from the table. And 8 minus 3 gives us our function value of g of -4, which is now 5. So we see that as 5. You can see the pattern. To find x -2 for g of x, let's see if this actually does it with us. Yes. We're going to put in -2 for x. -2 plus 2 is 0. So we're going to be finding the function value at 0, which on this graph is 10. And we're going to subtract 3 from it. And that's going to give us 7. Okay. For 0, we plug in 0 for x. 0 plus 2 is 2. What's the function value at 2? It's 12. 12 minus 3 is 9. So our value is 9. Now, if we try to find the function value at x equals 2, we plug in 2. F of 2 plus 2, which is f of 4. But the problem is we don't have 4 on our graph to find f of 4. So the reason why when we cannot do that, we don't know it from a table. So therefore we don't know what g of 2 is because we don't have the value to go off of. Watch this again if it doesn't make complete sense. It's really like a puzzle. You're plugging something in, you're going to find it, using that piece to find the next piece. It's like a little scavenger hunt. That is all for 3.5, y'all. We'll talk about it in class tomorrow.